As I'll ever be. All, all right. Welcome back to United Astronomy Clubs of New Jersey. Thank you all for joining us for our winter online only season here on Twitch and YouTube. Uh, we're getting into December now, so everyone's looking for that last minute holiday rush, but we're here to bring you more science and astronomy topics. Uh, so while we get into our presentation, do check us out on uacnj.org. It's our website where you can find a list of our upcoming talks, as well as links to our member clubs, information about different telescopes you can see when we are back on site come in the spring time, as well as any science projects we have going on there in conjunction with some of the local colleges. You can also check us out on Facebook, Instagram. We have a Discord server. All great options to get in touch with us, share your astrophotography, ask questions, get advice on your setup and troubleshooting for your telescope rigs, uh, and all around have a good time. You can also, we usually post on those places when we will be going live as well. Uh, as always, we are United Astronomy Clubs of New Jersey is a nonprofit. So if you are looking to donate this holiday giving season, do check out our website. We also have a Patreon, and all those proceeds go to helping us pay the bills. And oh, sorry, there's a sirens going by. So I'm apologize if there's lots of background noise. All right, looks like they cleared off. um, but if you're looking to help out this holiday season for a great cause, for bringing science and astronomy outreach to people, do check us out on our website. With that, you're not here to listen to me babble on. You're here for a talk, uh, and you're here for the What's Up in the December Sky with Lonny Buinis. I sorry, many sirens going very fast. I'm probably going to check that out after I intro. Lonnie has been giving the What's Up series of talks since UAC&J opened in 1994. He received degrees from Stevens Institute of Technology in physics and computer science, then learned space art, animation, and video on his own. Lonnie is the only member of the IAAA.org who specializes in virtual reality worlds and has wrote the first interactive space history ebook and is most pleased to have married his wife Jan, who is also his narrator. And with that, here's Lonnie for the talk.
Thanks very much, Kim. It's always a challenge when you're doing live presentations that things outside your control can happen. So no sirens here, but you never know. We're looking at a view of what's up in the mid-December sky. I picked the middle of the month, the 15th, at 18 hours. So for you arithmeticians out there, 18, just subtract 12 hours from military time to get 6 p.m. And at 6 p.m. in the middle of December, you can see 4 giant planets, 2 star clusters, and a partridge in a pear tree, because it's the end of the year, holiday season. If you look outside and face southeast, mid-December, you can find the planets Venus, Saturn, Neptune, Uranus, and Jupiter all in the night sky, as well as star clusters Pleiades and Hyades. And we're going to talk about all this in more detail now. I'm going to start by referring you to a couple of places to look online for information. I'll be doing this throughout. You don't have to write things down. You can just take pictures, right? Nobody knows how to write anymore. In fact, I'll bet no one out there knows what a pencil and paper is. It's been a long time since anybody used a pencil and paper or even a tablet to record information. But I like to go to go-astronomy or starwalk.space. Go-astronomy or starwalk.space for a list of events throughout the whole year, astronomical events. These sites have a lot more going on with them, but I focus in on the calendars. And I don't work for any of the websites that you're about to see. I'm not a professional astronomer. I'm an amateur astronomer, which means I don't do it for money, but love. So let's focus on the starwalk.space events, which are a little more complete because they include things that are happening in the morning sky as well as the evening. And instead of looking at things chronologically as I usually do, I'm taking a new approach. So it might be easier for us to remember what's going on by topics, like the phases of the moon, or when the moon is near something in the sky. Is it really near it, or is it in front of it? Think about that. Where is the moon in relation to the stars? We're going to also look at a good time to look at particular planets, Jupiter and Mercury. And then there are some unique events like the solstice, when the sun stands still. But I'm going to start with the phases of the moon. December 1st, new moon. December 30th, new moon. 2 new moons in 1 month. How is that possible? Right? There's 12 months in a year. 12 into 365 should be what, like 31, 30 and a half. But the moon's phases don't fit evenly into a whole year, 365 and a quarter days. They're about 29 and a half days. So you can occasionally have 2 full moons or 2 new moons in 1 month. So the beginning and the end of December, the moon is in the daytime sky. It's a great time to see faint stuff at night because the moon doesn't get in the way. When it does get in the way, it's the middle of the month. Full moon, lousy time to see star clusters, nebulas, which are clouds, gases where stars and planets are forming. So we're going to take a look at this by using a free program called Stellarium. You can download it, you can install it, you can run it off their website on their supercomputers, or you can put it on your mobile devices for free. So it all pretty much works the same in all of these things. This is my desktop version where I can zoom in and out. I can look at something familiar like the Big Dipper. But then I realize it's kind of hard to recognize anything like the Little Dipper because there's so many stars, it's confusing. 7 stars in the Big Dipper, 1, 2, 3, 4, 5, 6, and in the trees, 7. Did you know there's actually 8? Look in the handle. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so check out the middle star in the handle. Mizar is a visual double with Alcor. When I click on something, you're going to see titles pop up and alternate names for these things. Stars have names from many different catalogs. We're going to start with the Arabic name that was put there by Arabic astronomers during the Dark Ages. We still use some of the names of the brighter stars, like Alpha Ursa Major and Beta have the names Dubi and Merak. We can use the Big Dipper to find the Little Dipper. You know, it's really tough. If you buy a star chart from, shameless advertisement, UACNJ, or any science museum or planetarium gift shop, the star charts come with lines like these. Makes it a little bit easier to see what we're talking about. And I can also put up names, and I could even put up images if I wanted to from many different cultures, not just the Greek cultures and others that these are based on, the modern. Let's do without the pictures and without the data. So Big Dipper can help us find the Little Dipper, and then we know where north is. I don't remember where the directions are unless I've really memorized the position of the North Star, and that would be due north. So we can also cheat by putting on some markings. We can put up the cardinal points, and I'm going to use more than 4. So north, I'm going to make my way, once I find my way into the northern sky towards the west, I'm going to move to the left or west, where the stars that I talked about earlier in other What's Up talks earlier in the year are now setting, the stars of spring and summer. We've got a cross-shaped Cygnus, the swan. We've seen this before in What's Up in August and September, but now it's lying low on the horizon, and so sometimes it's been referred to as the Christmas cross. But I'm going to make my way on over to the south to show you what happens to the moon as it passes through the signs of the zodiac. I'll zoom out a little bit more the way you would see a star chart, a planisphere like the ones we sell in science museums, also at UACN gift shop. See, I lied. I said I'd advertise it only once. So if I were to zoom in and show you the orbit of the Earth spread out into space, projected out into space, the orbit of the Earth is called the ecliptic when we draw it in the sky. And you're not going, that's the year 2000. How about the current ecliptic? It's very slightly different. Over time, this has changed because as the Earth goes around the sun, it wobbles a little bit. So the pole only doesn't always point in the North Star. It goes in a big circle every 25,000 years. And so the ecliptic shifts too, which means right now there are 13 signs, not 12, 13 that the sun passes through, and the moon, and the planets. The sea goat, the water carrier, the fishes, the ram, looks just like a ram, right? No? Aries, the ram, Taurus, the bull, Gemini, the twins. You recognize some of these? Yeah, they help us find the planets. Look, Aquarius, Saturn is along that area, Neptune, Uranus, Jupiter in Taurus. So when I say Jupiter, the planet is in the stars of Taurus, do I mean it's about the same distance? Nope. Nope. Distance 4 astronomical units from us. What's an AU, astronomical unit? That's a distance from the Earth to Sun, which a lot of you have heard is 93 million miles, about 149.7 million kilometers or kilometers. You say tomato, I say tomato. So Jupiter is fairly close, 4 astronomical units. So it took light about 4 times 8 1/3, about a half an hour to reach us. Whereas the bright star Aldebaran in Taurus the Bull, 66 years by light. Big difference, half hour, 66 years. So when Jupiter is in Taurus, it's nowhere near these stars. So what happens to the moon over time? If I pick the same time night after night in the same direction, we can time travel. So right now, 7:53 at night. What happens if I look later on and later on at night? The sky itself seems to move. Why is that? Right, so by midnight, Taurus is much higher than it was earlier. And the planet Mars has risen in Cancer the Crab. Look at that. What's happened? I'm going to go backwards again to about now. Well, all right, just after 7 o'clock. Well, the Earth is rotating, right? As the Earth rotates, it spins on its axis. Looks like the whole sky moves. And that's why our ancestors thought that the heavens moved around the Earth. It's all relative. Depends on what you think is more important, your viewpoint on Earth or the universe's viewpoint with a spinning Earth. So let's pick the same time. Let's say 7 o'clock every night, starting with December 7th. Look at the moon. Same time the next night, the moon is no longer on the right side of Saturn, it's on the left. And its phase is going to change, right? On the 8th, the moon is half lit up. We call it a quarter phase, quarter moon. Why not half moon? Why don't we call it a half moon? Yeah, there's another side of the moon we don't see. The side facing away from us is half lit up as well, because the moon is a sphere, right? And so when you light a ball from a distant light source, half of it will be lit up. And if you look at one side, you'll see only a quarter. Now, if the moon is a ball, and Mars is a ball, and Saturn's a ball, and Jupiter is a ball, and the planets are balls, and the stars are round, why should we believe that the Earth is flat? This is a basic question I would like to ask flat earthers. But they have answers. They have answers for everything. So I'm not going to bother to ask. Over the next few nights, 8, 9, 10, the moon not only moves through the sky, but by the middle of the month, the 15th, it's much lower towards the eastern sky. I'm going to zoom in a bit so we can see the phase of the moon. Full moon on the 15th. The moon is waxing over the next few days and the next 2 weeks, getting larger because the phase changes. Is it really getting larger or smaller? No. No, we're just seeing more of it lit up. So the moon goes through phases as it moves around the Earth because the angle between the source of light, the Earth and the moon, keeps changing. What's the source of light? What's this light that we're seeing? Does the moon have its own light? No. It's reflected light from the sun, which is the light source. So if the sun is behind you, and then the Earth, and then the moon, all lined up in a straight line, can you see great shadow detail on a full moon? No. It's a lousy time to view the moon in a telescope, except for this one crater right here, Tycho, with bright rays shooting out in all directions. That's the best time to see the rays, debris thrown out by the impact of a huge body that struck the moon billions of years ago and created Tycho, one of the brightest craters. This is also the crater that was visited by people in the movie and book 2001: A Space Odyssey. Check it out. Interesting story. One of the frozen lava seas of the moon, something that helps us appreciate how small some things on the Earth are. This is about 500 miles across. New Jersey's about 200 from High Point to Cape May. I rode it on my bicycle once. So there you'd have a couple of bike trips going from High Point to Cape May here in Mare Crisium, the Sea of Crises. Mare Tranquillitatis, where human beings landed on the moon, much bigger. All of these seas have names. They're not water, they're frozen lava. So over time, the sky changes. Our viewpoint changes, and things move, like the moon and the planets. Let's go back a second. I was talking about the moon. Well, every month, the full moon has a name, and we call it the cold moon in December, although the Native Americans of different tribes had many names. I like the long night moon. There are some very poetic names. The popping trees moon. Why would trees pop? When the sap freezes in the tree, makes a popping, snapping noise sometimes. A winter freeze. How about long names? When deer shed their antlers moon. The little spirit moon. A time of reflection and introspection. It's a good time, speaking of introspection, to go out and contemplate the winter sky because some of the clearest and steadiest seeing is in the winter. And by seeing, I mean that the atmosphere itself is disturbed by temperature changes. And so when you look at the sky, at objects on a telescope that are low in the sky, they're coming through a lot more atmosphere and they warble and wobble. And the images get distorted. That's why stars twinkle. Best time of year to go out and see a clear sky is the winter. Not so great for comfort. Dead of winter moon, oak moon, a lot of poetic names. Very common one is the cold moon. I wonder why they call it the cold moon. So again, middle of the month, bad time to see anything else except your driveway lit up by the full moon. There are conjunctions, con, with, junction, together, a coming together of the moon near planets, Venus, Saturn, Jupiter, and Mars. And so if we want to see that, we can simulate it again in Stellarium. Over the next few days, the moon passes. Well, the moon is close to Venus. If you're lucky enough to get a good shot at the sky around the 4th and 5th, which is too late, and it happened already. Did anybody notice a bright thing hanging in the sky low in the southwest? Not twinkling and not moving like an airplane. That was the planet Venus, which itself goes through phases. I cannot see Venus very easily where I live because there are houses and trees in the way. Venus is in gibbous phase, just as the moon will be in another week or so. And the moon passed Venus in the past. Today, it's close to Saturn. In another part of the world, it will occult or hide Saturn, but we miss it. On its way past Neptune, in Pisces, the fishes, over the next few days, past Uranus, past Jupiter. Very cool conjunctions, meetings of things in the sky. You might see some Starlink satellites undergoing very quick conjunctions with a lot of things. Good time to see the planet Jupiter all this month. The Jupiter and the Earth and the Sun line up almost in a straight line. And we call that an opposition, opposite the Sun. So Jupiter is at its closest distance to the Earth. We can estimate that very quickly by using astronomical units. The Earth from Sun is what? One astronomical unit, 93 million miles. Multiply that by 500 million miles to Jupiter. So you see, miles quickly become useless to astronomers, too many to keep track of. So 5.2 AU for Jupiter, minus 1 for Earth. Jupiter is very close to us at 4 astronomical units. Takes light 8 1/3 minutes to go each astronomical unit. So 4 times 8 is 32, about 35 minutes or more than half an hour to see Jupiter as it looked in the past, a half hour ago. Whenever you look at anything in the sky at night, you're looking into the past. And the further away something is, the further back in time you're looking. You can time travel just by looking at stuff in the night sky. Ain't that neat? I just read a whole article about the use of the word ain't, which was acceptable English in the 15th and 16th centuries. And only later did it become decried. Ooh, big word, decried. Check it out. So Jupiter and Mercury, December 25th is Christmas, also the day before my birthday. Mercury, it is greatest distance west of the sun, west of the sun. You're facing south. Where's west going to be? Let's see. Facing south. So go outside tonight and look for the letter S, right? No. You're going to find the letter S. You're going to find an ecliptic up there? No. Should I make things a little bit harder? Sure. No ecliptic. No names? I'm going to leave the outlines up and the names of the planets. So you go out, look for the letter S. Nope. Look for south. And when should we look for Mercury? 25th. All right, so we can time travel in Stellarium and set the date to 25th. But when would we look for Mercury west of the sun? West is to the right. West is to the right, which means Mercury is going to be in the east in the morning. It's a morning star. So we have to go back in time from 19 minus 12 is 7 p.m., 6 p.m., 5, 4, 3, 2, 1, all the way back into the morning sky. And at 6 in the morning, that's when we'd see Mercury, the innermost planet, low near the horizon. I won't see it. Maybe some of you living near the shore or where there's a flat horizon, maybe an open field, will see Mercury. And just as Galileo discovered 400 years ago in his crude telescope, Mercury and Venus have phases like the moon. Mercury has a gibbous phase, which is not a type of ape. Gibbous, not gibbon. Gibbous phase. Mercury is a very difficult object to see. You can see why our ancestors got confused about its weird rotation. It was hard to observe except in the daytime, believe it or not. They actually looked for Venus and Mercury in the daytime. So it's very low above the horizon on Christmas, 25th. Unique events, meteor showers, we have 2. One is one of the best of the year. I talked about the one in every August, the Perseids from Perseus the hero. This one is the Geminids from zodiac sign. I'll let you think about that. Geminids. And the Ursids is minor at the end of the month. And then we have the solstice on the 21st. So let's take a look at the solstice. When the sun is lowest in the sky, the solstice happens this year at 4:20 in the morning on December 21st. At 4:20 in the morning, are we going to see the sun? Not if you're in New Jersey. If you're on the other side of the world, sure, but it reaches its lowest point during the day. So I picked, during the night, 4:20 a.m. is in the morning. Whoops. So I picked 12 noon to see that the sun is very low on the ecliptic, the path of the orbit of the Earth around the sun's projected into space. If we project the equator of Earth into space, we see that the Earth is tipped away from the sun. So the sun looks low in the sky. So the sun's light is spread out when it hits the ground. It's weaker. That's why we have colder weather. when the Earth is closest to the sun in winter in the northern hemisphere. Isn't that weird? The Earth is closest to the sun. It's not a perfect circle, it's an ellipse. So the Earth is actually at its closest point to the sun in New Jersey winter or in South America summer. So they have hotter summers. These cycles change. Sometimes in the distant past, New Jersey had more extreme summers. These are called Milankovitch cycles, and they contribute to global warming to an extent that most global warming alarmists ignore. So there's a lot of astronomy involved in global warming. The sun determines it all. Things are more complicated than made out to be by simplistic notions. So we have to be careful about complex scientific topics. So that's the solstice, when the sun, Sol, stands still in the sky. We have the longest nights. And our ancestors noticed by Christmas, by 25th, the sun was coming back. The days were getting a little bit longer. They were very observant. I think our ancestors were more observant than we are. We tend to be very busy with our devices, not looking up in the sky anymore. If you don't look up at the sky, you'll miss a minor meteor shower, 10 per hour, which means you'll see either 0 or 1 bright one every hour. On the 22nd, that's the peak, although there is a bell curve. The meteors happen over a period of time as we enter the debris field of an old comet. In this case, Comet 8P/Tuttle. We get into its path every year. The Earth crosses into that pathway of the debris left over from the comet. And that's why we have meteors. Little tiny, mostly tiny pieces of rock about the size of a sand grain burning up in the atmosphere, 33 kilometers per second. That sounds pretty fast, right? It's many times the speed of sound, but that's considered slow. Fast meteors are like 70. And so check it out, December 22nd. If you don't see them radiating out from near Beta, second brightest star in the Little Dipper, don't worry. You have a better chance with the Geminids from Gemini. They seem to radiate out from Gemini, just as railroad tracks seem to radiate out or meet in the distance, and then the tracks radiate towards you, right? In all directions, if you had more tracks, right? So it's an optical illusion, right? They're not meeting in the distance. They never meet. Parallel lines, geometry, basic geometry, never meet, but they seem to meet in perspective. So what are they coming from? Not a comet, as most meteor showers do. This one, unusual, and the quadranted meteor showers are the only ones that radiate debris, that have debris in a track from maybe an asteroid, right? A solid clump of rock. Comets are kind of loose collections of debris that melt, that sublime into gases, and that's why we see the tail, the gaseous tail. That's an actual radar picture made from Arecibo Observatory, which has fallen apart, unfortunately, of 3200 Phaethon, an asteroid. These are a little faster, 35 kilometers a second. Zenith hourly rate, the zenith is right overhead, directly up, 120. Now, I don't expect you're going to see 120 meters an hour. Where we live, there's a lot of light pollution. You might see a few bright ones, but be patient. It only takes certain specialized equipment to view meteors. And you have a chance from now through mid-December if you miss the peak on the 14th. What do you need? What do you need to see a meteor shower? Well, there are some stringent conditions. I hate to break it to you. You need, number one, a comfy chair. And you need maybe some soft cushions to go with that. You also could get a vintage 1970s vinyl summer lounge chair, the kind you might have used to use at the beach. Some of us old folks had things like this. They're now falling apart. I used to repair them. They'd fall apart as fast as you can repair them. And this one you can get for only $280. That's up to you. You also need to bundle up, right? But you want to be sure that you can move. So don't buy the Christmas Story snowsuit. This one's only under $50. You don't really need to do that. And what else do you need? You need your eye, your naked eye. And that's all you need because your eye has a wide angle field of view. Meteors stream out from the radiant point all over the entire sky. So you don't need a telescope or binoculars to appreciate a meteor shower. You do need patience to appreciate the fact that that darn T corona borealis hasn't exploded yet. We've been waiting since April through September for this every 80-year thing to explode. And it is material sucked off of a giant red star falling onto the accretion disk, a disk that collects around a white dwarf star the size of a planet, about the size of Earth. It's tiny. The red giant, big enough to swallow up our inner solar system. This is artwork. This is not a real picture. This is artwork by the oldest living space artist, David Hardy, who's now 87 years old. The Blaze Star. These are a close orbiting binary pair. This is artwork that we're looking at, not a real image. We don't know what it looks like for sure, but we have a pretty good idea. What happens is every 80 years, this thing brightens by 1,600 times from being visible barely in a small telescope, being visible at +2 to the naked eye, being as bright as stars, as the other stars in Cassiopeia, where it will appear. I'm sorry, not Cassiopeia. Uh, Corona Borealis. Corona, crown, Borealis northern. And we know that this will happen because it did. It dimmed in 2018 and brightened just before, it dimmed and brightened in 1946, and just before that. And so it's done the same thing in 2018 and last year. So we expect it to explode anytime now. I'm waiting. Unfortunately, Corona, the Crown, and Hercules are summer constellations, so they're not in the night sky anymore. They're in the very, very early morning sky. So if you get up at 6 in the morning and look straight up, you look for a little red circle near Epsilon Corona Borealis, right? No? No. You don't look for a little red circle. You don't look for a white circle, and you don't look for blue lines. But I drew these lines next to epsilon and delta in the crown. See the crown? And that's where you're going to look to see a naked eye star just as bright as these other stars or brighter. Happens every 80 years. I'm very anxious to hear this. And I'm sure that the news media, the major media, as they usually do, will devote a full 5 seconds to this when it happens. 5 seconds. You got to be fast. We were looking for news about the drones over New Jersey. They devoted a full 20, maybe 15 seconds last night. Wow. How do you get started in astronomy? I'm going to wrap things up shortly and leave things open for questions. Well, you can start with binoculars, because if you get bored with astronomy, you can use them to look at birds, right? Or baseball games or football games, whatever the season holds, right? And the prices of giant binoculars have come way down. Big ones. Standard binoculars are 7 by 50. The first number is power, magnification 7 times bigger. Second number 50 is millimeters, the size of the lens. 50 millimeters is just about 2 inches. So giant binoculars, 20 by 80. Wow, that's much bigger. And for us people, us older folks with pupils that don't open very far as they used to, these are a better idea than ones that have light cones so big that not all the light goes into your eye. Some of you might be interested in starter telescopes. Celestron has one called First Scope for only $72. When I was young, you had to spend at least $200 to get a good beginner telescope. But there are all kinds of prices, all kinds of formats. Newtonian design uses a mirror in the back that bounces light to a second mirror there that bounces it up out to your eye or a camera or your cell phone. There's a lot of ways to do things. Refracting telescopes use lenses, lens in front, lens for your eyepiece in the back. And if you want to spend a little bit more to get a lot more light to see faint objects like nebulas, gas clouds, or some star clusters, 8 and 10 inches, you are fairly economical. I know these prices look a little intimidating, but optics are expensive because they're hard to figure. It takes expert work to make them. Although amateur astronomers can tell you how to grind your own mirror. It can be done. It can be done by amateurs. You don't have to be a professional. Dobsonians are the most economical, larger telescope design. Simple mount, but nice big mirrors. And then my wife gifted me with a very nice complex multi-optical design. This one is a variant of Cassegrain, which uses a mirror in back and a second mirror in the front that bounces the light as it goes in, up, and back through a hole in the main mirror, making the whole telescope very compact, very small. But it has a long focal length, 1.25 meters. Quick, divide that by 0.3048. Any mathematicians in the audience? I had a friend who got so annoyed when people would say, do the math, because 1.25 meters divided by 0.3048 is not math, it's arithmetic. My friend used to shake his finger at me and make it clear that there was not advanced math. He went to MIT. I refer you to UACNIJ. Repeat after me. United Astronomy Clubs of New Jersey. UACNIJ. I don't hear you. UACNIJ.org. Go check out our website. It's an umbrella organization of many different clubs from not only New Jersey, but New York and Pennsylvania as well. You can, if you like to read, if any of us still read, anyone out there, raise your hand. Can't see you. Sky and Telescope and Astronomy, great for laypersons like ourselves, non-experts, right? Written at a level we can all understand. They've been there for decades. UACNJ gives away some old copies, I believe, of some of these. But you can also sign up online. You could subscribe, or you can get large parts of their websites for free. Check out space.com, easy to remember, right? Space.com has a lot of different topics. And they also have a list of the best stargazing apps, best-stargazing-apps. And I counted 21 just for Android because I have an Android phone. Sorry, don't mean to discriminate against you iPhone holders and owners. iPhones are perfectly fine. No, I don't hate iPhones. I don't hate Apple. I don't. I think everything is useful. 21 Android apps. Some are designed for Apple users. Look at that. Night Sky 11. I've been using Skyview and especially Stellarium, the mobile version. These are all free. It's amazing how much free stuff there is. I believe there might be a paying version that upgrades Stellarium with more objects, but really you can get started for free on your any mobile device, all for different purposes. Check it out. The online version of Stellarium, very similar to what I'm using on my laptop, is at stellarium-web.org. And here I simulated the sky for 20 hours. Minus 12 is PM on 12/15, December 15th. And that's pretty much what we saw before. This is the mobile version. You can do this on their website or on a mobile device, and there is yet another version, Stellarium Mobile, that I mentioned before. Celestial lets you fly through space. This is really cool. You can go to another planet, like or moons of other planets, like Iapetus. Iapetus is a moon of Saturn that orbits at an angle to Saturn's rings, so you can see the rings open and close every 79 days. So, to review. Oh no, you didn't think there'd be a review and a test? Yes, there is. Lunar phases. Great time to see stuff at night is early December and late December. Not so when the moon is full in the middle of the month. The moon moves past a lot of planets Early in the month, it was near Venus. It's near Saturn tomorrow night, then near Jupiter in the middle of the month, and later on near Mars. If you stay up a little bit later, like towards 10, 11, 12 midnight, you can see the moon get close to Mars. Again, no occultation here in New Jersey, sorry. But it's going to be close. You might be able to get them in binoculars together. Look at Jupiter. It's bright. It's that thing that's high, that's bright, that doesn't twinkle, to put it very simply. Go outside on a nice clear night. You can't miss Jupiter. Beautiful. King of the planets to the ancient Greeks. Saturn was leaden in color and slower than Jupiter. And so the Greeks thought it was the god Jupiter's father, Saturn, or Cronus, the father of time. Mercury on Christmas. Check it out. And don't miss the Geminids. You can forget the Ursids, unless you're a fanatic. Geminid meteor shower, middle of the month. Go outside. Best time is midnight. If you can't, go earlier. Best time, you're looking right down the shadow of Earth into a nice dark sky. And the solstice happens on the 21st. The sun will be coming back after that. The days will be getting longer, never fear. And so before I go back to the night sky and leave it up for questions, I want to leave you with moongiant.com, where you can print or look at a beautiful calendar of the phases of the moon, which almost all happen to line up on the same day, Sunday. Look at that. Happens every once in a while. 2 new moons. You can find my 3D models of planets and the moon, and how the Kepler Space Probe works, which you can work with your fingertips for free. These are virtual reality objects at astronomyinmotion.com, which are things that you can use a mouse or your fingers or a joystick to move around, to zoom in on, to click little hotspots for videos, especially the free version of Mars at your fingertips. It's for sale. The 4K version is for sale. The HD version is free, and you can hear my wife Jen narrate videos that I never paid her for at Mars at your fingertips. Check them out, Astronomy in Motion. Check out UACNJ at Discord, Instagram, Facebook, YouTube, or our own website, uacnj.org. I want to thank you for being a very patient and kind and curious audience. Thanks.
All right, Lonnie, thank you for another great presentation. Um, Also, uh, to add to that slide at the end, you can also check out our online merch store. It's store.uacnj.org. Uh, if you're looking for a holiday gift for that astronomer in your life, you might want to go check that out, especially since it ships. So you want to give time to for it to get there before Christmas. Um, so we're gonna get into question and answer, which was a little light, but I think everyone's kind of gearing up for the holiday and doing their Amazon shopping. So one of the questions we had was, do you own any meteorites or have you gone hunting for them?
I had a visitor to UACNJ when I was giving the talks live one year, gave me a little piece of Mars, because we know that certain meteorites have the same exact chemical composition of stuff that was on Mars, got blasted off and made its way to Earth over eons. So somewhere I have a tiny, it's really small, bigger than a sand grain though, of Mars. But other than that, no. We have various club members who belong to clubs that are part of UACNJ, are expert meteorite collectors. Alan Whitskill, for instance, at AAI, Amateur Astronomers Incorporated in Cranford, has given many talks about meteors. Quite expert. There are others. There are lots of people who have great meteorite collections. They wouldn't have meteors because those are coming through the atmosphere. Good question.
Yeah, Alan actually donated a number of the meteorite specimens that we have at on display at our location in Jenny Jump State Park, which unfortunately we are not open to the public there during the winter. It gets very cold, and it's a state park. Ice and slipping and snow is a hazard that makes insurance rates go way up. And as a nonprofit, that's a little too much. All right. So, online, if you have any questions, do get those in. Um, like I said, we were a bit light this time, but I want to
Uh,
thank you, Lonnie, for another great presentation. Thank
Thank
you
you,
all
Kim.
for joining us week after week. Um, I believe we're up to like over 600 subscribers on our YouTube, so that's awesome to finally reach that goal. Uh, and we have n number of 128 followers on our Twitch channel. Uh, so if you want to see more of this type of online space, astronomy and science topics, do hit those like and subscribe buttons. They're the free ones are always great. Let us know we're doing a good job. And
I
it
left
looks
I left out while we're waiting. I left out a few very nice objects to see in the winter sky, and those are bright stars like the constellation Orion, which has a very nice nebula gas cloud in the sword hanging below the belt of Orion the Hunter.
yep.
So there's lots to see, lots of good stuff to see in the winter sky.
You can also check out the tiniest of spoons, the Pleiades, the Seven Sisters. So it kind of looks like the tiniest of dippers.
Yeah.
Like that. All right. So since it looks like our questions are pretty much dried up, thank you all for joining us. And until next time, clear skies and good seeing. Have a good night.
Good night.